everyone. This is Daniel Clark. I'm joined with Amber Burnett and Edward Fry. Today, we're going to be walking through the Microsoft Azure portal as well as its elastic database tools. Since we live in a world of big data, this can lead to big problems, and we think tools like Azure and elastic database can offer big solutions to help solve them. To go over a quick agenda of what we'll be talking about for the next 20 minutes or so, we're going to start with software as a service and some of the issues that it can face and some of the challenges that practitioners have to solve. We'll go through some of the solutions to some of these challenges using some of the elastic database and Azure toolkit. And then from there, we're going to talk about elastic databases in general, what they are, how they can help solve problems, and then go into a demonstration of how you can build your own. And we're going to have like a pretty good use case scenario using some example tools and some example data, teaching you about Microsoft Azure and then teaching you about elastic databases and how they can work for you and help solve some of your data problems. Going into software as a service in general, this is kind of built around the concept of one vendor or company building like a single application that many customers can use. It could be like Chase.com, where many customers can use them as a banking service and go on their app to kind of view their banking information. Kind of a relatively simple concept, and many customers use it. And this is sort of built around the concept of multi-tenacity, where many users are using the database as if it's an apartment building, and the users are kind of residents within the apartment building. So each user has its own database size based on what they want to pay for, and then some of its very specific tools, some very specific use cases based around what's available in the system. Some of the examples of software as a services would be Microsoft Office 365, which I believe is probably the most popular one that we're all familiar with. The next would be Adobe Creative Cloud, as well as some SaaS software that you're familiar with from the stats classes, as well as GitHub. So obviously, like software as a service can take on many different formats and designs to kind of meet any sort of data challenge based on kind of the users of today.
As Daniel said, we will walk through the next few slides with the data management requirements. They are broken into two sections: fundamental rights and service level agreement rights. First, security. One of the biggest challenges of SaaS is security, considering all high-profile cases where companies are hacked and customers' data is exposed. Fundamentally, these start from the principle that if one customer is compromised, then everyone else will be too. For example, MapKeeper in 2015. This was a case where a single user was hacked, and then this led to an exposure of millions of Mac users' data being vulnerable. Next, we'll move on to privacy. An important benefit of software as a service is ensuring that each customer is not seeing other people's data. Now, let's think of an example, Chase.com. If you have your own account, then you would not be able to see other people's accounts as well. So this is very important not to leak out other customers' tenant information. Also, isolation. Continuing on, scalability. Unpredicted burst of usage, which can drag down the performance of the software as a service. It's very important for companies to be able to adapt for certain situations that you can't always predict. For example, if your business grows, let's say over the span of a year, your business can actually scale up, and also think about it allocating for unanticipated burst of usage, such as in seasonal or periodic times. Then we're going to go on to performance. Unpredicted surges in one customer's usage can affect the entire database. Let's take into consideration here the noisy neighbor. All other customers will also be affected. We want to ensure that each customer's service level agreement is always met. Another example here. Jennifer Aniston and Instagram. Now, Instagram did not know that she was going to post her photo with all of her castmates on Friends and Join. All of a sudden, millions of people came out to check it out, and Instagram servers crashed. We don't want that to happen. And finally, availability. It is possible to access a database suffering from poor performance, but it is not possible to access a database that is unavailable. So here let's consider, when does poor performance turn into unavailability? If performance will suffer or does suffer to such a great degree that the users of the database cannot perform their job, well, the database has become unavailable.
Let's talk about the solutions to some of these problems. The goal here is that we need our software as a service to meet these various service level requirements that Amber was discussing. And there are some different approaches that we could take. We could look at things like provisioning a different database for each user. That might meet the requirements, but it's going to be very expensive. Or we could look at the opposite scenario where we have one database for every single tenant in the system. That will be much cheaper, but we run the risk of not meeting our requirements, things like privacy or performance, because everyone's in the same database. The solution to this is what you see here on the slide, a single tenant application with a pooled single tenant database. This lets you have a separate logical database for each single user in your software as a service. However, you're pooling them together, and that saves on cost. We're able to meet our requirements and do it in a budget-friendly way. Now, what is a SQL elastic pool? It sounds like a very fancy term. Well, basically what we're doing here is we're taking multiple databases and we are putting them in a container. Think of like a folder on your file system, only it's for databases. And this container is called an elastic pool. It's called a pool because there's more than one thing in it, but it's elastic because we can change it. We can make it bigger, make it smaller, scale it up and down, which is to say throw more or less resources at it. We can also scale it in and out, which is to say add or remove instances of the database from it. So we have a lot of flexibility, and that's the elasticity portion of this pool. So what about variability? What happens when a new tenant comes along? Well, it's also very easy because we can add or remove these databases dynamically at runtime. We don't need to stop anybody's software as a service to add a new customer or to remove a customer who's decided to leave the service. We also have scalability. So what happens when one customer needs to use a whole lot of application? We can actually set these elastic pools up to automatically scale up when they detect enhanced usage. We don't need notification from the customers. We don't even need to manually monitor these things if we don't want to. The pool will take care of it all. And then when they're done using the additional resources, the pool can scale itself back down in order to save on cost. So when do you want to use a pool? Really what you want to look for in order to determine if you're going to use one of these elastic pools is seasonal spikes. The idea here is that different users are going to have different spikes of usage. For instance, if your software as a service is an e-commerce application, you will likely see a huge spike from your retailers who are running sales over the holidays. So from the end of November, maybe through the beginning of January. However, other types of customers, maybe a flower shop, their spikes correspond to different times of the year, Mother's Day and Valentine's Day. And so because these spikes vary from one user to the next, we're taking advantage of that fact to basically let us bill on the average cost versus the maximum cost that we could possibly see. And that is where the savings come in.
A few ways that people use to sort of figure out how they're going to provision their resources is they can actually use some algorithm models that will in real time sort of scale the database based on how the resources are going to be provisioned. And historically, people have been using some predictive models based on like previous data that's been running, that's been available to predict and sometimes pretty accurately when a database is slated to spike based on some seasonal trends in the past. One example of a company that's kind of shown a lot of savings through elastic databases is this Tunisian software vendor for the travel industry called Cybressa. This particular company has been seeing about 10,000 bookings per day, and they employed a recent elastic database model which shifted their average DTUs from 50 to 20, they were able to kind of see a $240,000 decrease in costs to manage their databases, which at a scale for a company like Cybressa, that's going to be massively significant to help them reduce costs for the year. And here's our tutorial.
To give a deeper dive into Azure and Elastic Database pools, we're going to provide you a step-by-step tutorial so you can build your own and to help you better manage your databases. Within this tutorial, let's get started on what exactly we're going to cover. You're going to be going through 7 different tutorials covering cloud computing with an Azure overview, a PowerShell overview, and then a getting started section. Then we'll move to tenant provisioning, pool load, next restore tenant, and finally cross-tenant distributed queries tutorial. For all of these demos, we will utilize a sample Azure application called Wingtip SaaS. Cloud computing is a game changer in the industry that has changed the landscape of application architecture. Let's just consider that cloud computing services are more advanced and more users are allowed to access sophisticated software than ever before. Basically, think of it this way: unlimited computing power. Some of the market leaders, as shown here, are Google, Microsoft, Amazon, and IBM.
So to define cloud computing involves delivering computational services over the internet by way of a virtual machine, which users can access or pay to access. These can involve the following services: server applications, storage applications. It can also involve databases, networking, whether it's social networking or computational networking. It can involve specific software access, such as SaaS software. It can involve analytics, which revolves around SaaS as well. And then intelligence software, which is something the government can use. Examples of cloud computing applications can involve creating cloud native applications. It can involve storing and backing up and recovering data that is lost. You can also use cloud computing to stream audio and video, as well as share audio and video. And then as well, you can deliver software on demand. And this is one of the biggest kind of breakthroughs in the industry, is being able to share software easily and quickly. And then you have testing and building applications. And then from there, you can analyze data using cloud computing, and then you can embed intelligence. Microsoft Azure in specific, one of the tools that we're going to talk through today, is an ever-expanding toolbox of various cloud computing services. Azure allows users the freedom to build, manage, and deploy applications on a massive global network using your favorite tools and frameworks. And Azure itself employs dozens of different tools to help users to manage their data and manage all their software needs using like their cloud computing platform.
Amber here again. As Daniel just touched on, Microsoft Azure services are shown here. Start please by viewing at the top left icon. Here we have Azure Cosmos DB. It is a hosted NoSQL database for any scale. Moving right, we have Azure Media Services. This offers cloud-based video playing, indexing, transcoding, and content protection services. Again, moving to the far right top, we have Azure DevOps. This provides services for teams to share code, track work, and ship software. We know you and your team are going to definitely want to utilize that. As we transition down from the far left icon, we have Azure IoT Hub. This offers various options for things like interconnectivity and monitoring devices. Moving right, we have the cute elephant, HD Insight. It's basically a personalized Hadoop deployment. And finally, the far right bottom corner, we have Azure Redis Chase. Now, this is a controlled version of the widespread open source Redis data structure server that you're already probably familiar with. Azure Cloud Services. Using a cloud service allows us to focus on the benefits of elastic pools on an equal plane. This avoids us from having to create, install, or manage the underlying technology. Now let's look at a few key advantages. Cost management. This keeps the cost down. On-demand provisioning. You're basically able to spin resources up and down as you need them. Elasticity. Think of this as automated provisioning. Scalability. The scale that meets your usage. Multi-tenancy. Allowing for multiple users at the same time. Availability. It is there for you at all times. Hybrid data centers. They combine a traditional on-premises data center with the cloud. And reliability. It doesn't go down like consistency, even if something does happen. Consider it here like asset properties. And now let's see this in action with Edward. He will tell us how it all works.
All right, with that introduction out of the way, let's take a look at Azure. Now, I'm only going to focus in this talk on those features you need to understand a little bit in order to follow along with the Elastic Database Pools demo. There's a lot out there on Azure, entire courses, entire books, so if you're curious, I recommend that you go and check that out. In addition, if you've never used Azure, you can sign up for a free account. You get $200 worth of Azure credit that you can spend in the first 30 days. So that's definitely something that you can do. It's tied to your email. Just do a search for Azure and you can sign up. Now I have already signed up, so in the interest of time, let's just go right out there. To use Azure, as you see here, we go to portal.azure.com. Select the account that is associated with your Azure subscription. You will see we've got our various services that are available to us. What you see here is a dashboard, but one of the nice things that you can do is create your own various dashboards and reference those as you go through. Right here you can see we have dashboards available, so I'm just going to click that. And you can see some items on here. Now these are not active right at the moment. These will become active later on as we start going through things with the Elastic Database Pools. But the nice thing about these dashboards is you can have as many of them as you want. You can pop this new dashboard here to create a new one, so you get all kinds of different views into your resources and move them around as you like to suit your needs. And it's super easy. You just hit edit here, and then you just grab these little windows and move them around. There's little customizable widgets up here on the side that are contextually sensitive for whatever kinds of resource display you need to see. And when you're done, you just click Done Customizing. One of the key resources that you're going to see here is going to be a SQL Server database. For one of those, you just come over here where it says SQL Databases, hit Create, you pick a subscription, you pick a resource group. I strongly recommend that you use resource groups. These are basically containers. Think of them, a good analogy would be like folders in the file system, right? A folder holds other folders and files. Well, resource groups, they don't hold other resource groups, but they do hold other resources within your Azure subscription. So they let you group things together in whatever way makes sense. In our case, we're going to group everything together into an elastic database pool resource group, right? The little green check mark means it's unique. We hit OK. And down here, we're just going to enter a new database name, and we're just going to call this new SQL EDP. And we're going to select a server for that database. Now notice you do need a SQL server. And I could have started by creating the SQL server, but I wanted to show you that you can also create these on the fly if you want to when you are creating your database. And we'll give it some unique number. And now you can see it works. The specified server is available because these have to be unique. And then we're going to enter our login information here. So I'm just going to enter my information. And for passwords, enter a nice strong password. There are password rules. And select where you want your server to be deployed. I'm in the US, so it makes sense to go ahead and select a United States location. I'm going to choose North Central US. And now it's going to create the server for us, the SQL server, and then create a database on that server. And you can have more than one database per server. Now it says here, want to use Elastic SQL Pool? Well, you can. You can pop yes here, and that's super convenient. But I'm not going to do that because we're going to go through that in detail later. Now once you're done, you hit Review plus Create. It gives you all this other information that you can read. And I want to call up here, notice you can do additional networking, there's other settings, tags. I'm not going to go through this in super great detail, but basically that is how you create a SQL server and a database on that SQL server. Notice your deployment is underway. This will take some time, and you can see up here in the corner there's a series of notifications, and you can just select that, and it shows you, in this case, that our deployment is in progress. In Azure, we have this concept of storage accounts. So under the covers, it had to declare a storage account for us. And that's where the data, the actual files on the disk are going to live. They're going to live in this storage account. Now you can specify your own storage accounts, of course, but if you just want to do something very quickly, you don't have to. It'll assign a unique identifier there. Provision the storage account. You see this one just came back okay. And then provision the server on top of that. And then provision any databases on top of that. So let's let that continue running. Come back over here to our dashboard. Come back to our favorites. By the way, you can customize this, all these favorites over here to suit what is actually your favorites. It comes with some nice suggestions out of the box for common things. Now, another aspect to this demonstration that is important is we're going to have a website. And in Azure, websites are called app services. So if you click app service here, and you can create a new one. Now, I showed you earlier how to do it from that favorites list. You can also come up here and click add. This is for anything, right? Not just app services. You can come down here and click the big blue box. They make it pretty easy to figure out where to go to make one of these. So we're going to create a brand new app service. And your mind, just keeping in the back of your mind, this is a website. Now, just like we had with the database needed a server, right? A SQL Server deployment, and the server needed a storage account. Under the covers, have to have the storage account. Well, with these web apps, it's the same deal. Under the covers, we have to have an app service plan, and we are going to get to pick that right down here. Now let's start by going through some of these things. Now we just created a resource group a second ago, so I'm going to pick the same one, the Elastic DB pool. We're going to give our web app a name. We're going to call it Elastic Web App. You can either deploy a straight traditional web app with code, or you can use Docker containers. We're just going to use code here. For your runtime stack, you can select what, there's a lot of technologies here. What do you want your web server to be, basically? And we're just going to pick .NET Core 3, Linux or Windows. So if you do an Apache or something and you want Linux, you can do that. The region, it's going to select our region here, Central US. I'm going to pick the same one we had our storage account in. That'll make things run a lot faster if we're all in the same region. So North Central US. Now down here on App Service Plan, notice it did the same thing. It assigned, it took our name, Elastic DB pool. It put an ASP on the front. Very quickly, take a look up here. Deployment succeeded, our notification. So our new database is done. It basically built a name up for us out of our code technology, in our case ASP core, the Elastic Database Pool name, and then a unique identifier in the end. So it does that automatically. If you want to make your own web app service plan, you can do create new. You can also come down here and change the size, and it's this app service plan that determines how much you're going to pay. So how beefy of a server do you need, basically, is what we're taking a look at here. And there's a bunch of different options up here. You've got dev test, production, you can do some isolated work, all kinds of different features that you can select from your compute to your memory, storage. Do you want a traffic manager? And then up here you can see some recommendations for sizes. Additional options here has even more. So the estimated price, notice down here at the bottom is what it is, $175 for that one, $219 for this P1. You need at least an S1, which is what we have selected here for your pricing tier. We're just going to roll with that. And when you're done, review plus create, and that's it. Now it's going to go out and it's going to make that website for us using that app pool. Okay, now you see here, deployment is in progress. Now while that's deploying, we can do a little drop down here, go to our deployment succeeded, go to resource. Now remember, this is our database. I was just showing you how to make a database. There we go. Now it's all made. You see you have your resource group here that we selected earlier. There's my subscription ID, the location that we selected. Up here's the fully qualified server name. You can see these always end in database.windows.net. No pool. Development work, you can get your database connection strings here and so on. There's all kinds of information here. And then over here on the left, we have all sorts of different settings that we can use. Frankly, it would take probably hours to go through each and every one of these settings, but I just want you to know that they are here. As we go through other demos, you'll see me coming over to these settings, and there are settings for every resource in Azure, coming over to some of these settings and changing a few of them so that we can see our demo in action. But just knowing that that's where they're at is enough for now. There's two other things I want to show you real quick, and then we will be done with our little Azure demo. The first is Traffic Manager. All we need to do is hit create a resource. This will take us to the creation page where all the resources that are available are listed, and we can just simply type in Traffic Manager. Traffic Manager is a front end to your app service. Strictly speaking, you don't need it. However, if you have your web application deployed to multiple servers or to multiple data centers in multiple regions, you're going to want a traffic manager. This is a front end that sort of manages the routing of the networking for you as people try to connect to your web app instance. In other words, if someone from, say, Brazil tried to connect, the traffic manager would be smart enough to route them to an instance of our app in Brazil rather than trying to route them all the way up here to the US, so they get nice fast performance. I'm going to create one of these. It's actually pretty minor to what we're doing today, but you will see this in our demo. And then the final thing is the Elastic database now. And we're going to do the same thing. We're going to create a resource and we're going to type in Elastic. And you have here the SQL Elastic database pool. You will see us create these. today. Here's a little description of what they are. There's all kinds of documentation and so forth down here. Some plan information here that you can review. And then, of course, you would just do create, walk through the wizard just like we've done for both databases and for the website. And, of course, we're going to walk through that later, so I'm not going to spend a lot of time on it now. Finally, notice over here our deployment has succeeded. And these deployments can take some time sometimes, by the way. So be patient. In our case, the website and its underlying app pool, or app service plan, rather, has been deployed. We're going to go to that resource. Like we saw with the Elastic databases, we have a whole lot of knobs and dials over here to twist and turn. Even more actually for websites than we get for databases. Quite a lot. Up here we have key information, resource group, our North Central, etc. The websites by default will deploy with this azurewebsites.net domain at the end of the name you gave it, which in our case is Elastic Web App 007. So all of this is completely customizable, and if you want to browse to your new website, you just click the link there and boom, here's what you see by default out of the box. Once we deploy code, of course, we'll see our code and not this start page. So that's it. We know enough about Azure to be dangerous and to hopefully understand what's going on with some of the demos today. Let's take a look at PowerShell next.
I had a demonstration on how Azure works. The next we're going to walk through is Microsoft PowerShell. To define it, PowerShell is a task-based command line shell and scripting language built within the system administrator. It uses the Windows command line or terminal in the Macintosh computer, and it uses a net framework which is available from PowerShell. And essentially what this does is allow the users to access and manage these databases directly from the command line. And from here, that rapidly automates tasks. Doing this, it allows users to rapidly automate tasks that manage operating systems and processes. Some of the advantages of using this is that PowerShell allows users to control out Azure directly from the command line, as I discussed previously. Another would be that it allows providers to let users access data stores, such as a registry and certificate store, as easy as you can access the file in a system. So this allows for really quick and rapid management without using like a lot of kind of application software to slow down the processes. In addition, it includes a rich expression parser and a scripting language that can be learned and expressed across many different applications. And some of the design goals within kind of PowerShell is that PowerShell improves command line scripting environment performance with the following focuses. It can be through discoverability, consistency, interactive scripting environments, object orientation, and easy transition into scripting. So from here, we're going to have a demonstration on how PowerShell works so you can kind of see it in action.
Okay, let's turn our attention now to PowerShell. Now, as with Azure, PowerShell has a lot of capability. Just like with Azure, we're not going to try and cover every single thing there is about PowerShell. I'm just going to give you the basics so that you can follow along with the demo scripts that we will be talking about today. So to get started with PowerShell, it's very easy. Come over here to your Start menu. There is a PowerShell available for every system. I should call this out. My demo today is on Windows, of course. If you're on a Linux or a Mac operating system, you can download PowerShell, just do a search for it, and download the appropriate version for your computer. You can come up here and open a simple PowerShell prompt. If you're comfortable with the commands, you can come right in here and use those commands as you like, right from the prompt, just like you would a command prompt if you're used to the old DOS command prompts, the ones that are black with white letters. This is very similar, except it's blue. And we have this little PS right here next to our prompt. What I recommend, though, for someone who hasn't used this before is what we call the ICE editor. That's ISE. You can search for it with Cortana, press enter, and it'll load right up. Now this is nice because you not only have your PowerShell down here in this blue area at the bottom, so you can type direct commands just like you can with the other one, with this one. But, in fact, I'm going to get rid of this one right now. In addition to that, you can also type in your scripts up here. And so it's a very nice little IDE. It's fast. It's pretty lightweight. Of course, lots of things will let you edit PowerShell scripts. There's all sorts of other IDEs out there like Visual Studio Code, and Visual Studio itself, and I think JetBrains has one. You know, there's a ton of them out there. But honestly, this is the one that I usually use just because it is particularly suited to PowerShell. So let's talk about some commands. We'll come back to scripts in a little bit. I'm going to make this a little bigger. First command that anyone learning PowerShell should learn is called get help. And you will notice too, the format you will see for PowerShell commands is always going to be verb-noun. Some of them are short like this, get help. Some of them might be very long, like set dash, 5 adjectives followed by a noun. And if you type in get help, just type the command that you want help on. So if you're used to maybe the old DOS style commands where you do a /? to get your help, this is how you do that in PowerShell. Get help. And in fact, we're going to get help on get help itself. And when you hit enter, it gives you some basic information, as you can see here, about that command, the name, the syntax, things that are available. You can also do things like add some flags out here to the end. Flags in PowerShell are denoted by dashes, and the IntelliSense comes up here in the ISE editor, which is super nice. You can select if you just want to look at examples. You can ask to pull up the help page that's online. You can do full, which I find super helpful, so we're just going to hit dash full. And as you can see, there's a lot of information out here, and you can just kind of scroll up and browse that as you wish. So, get help. Remember, get help. Now, another thing that a lot of people coming to PowerShell want to know are what are some of the common commands to do things. So let's say you want a directory of information. In other shells, you would type something like dir maybe, or ls. Let's see what happens if we do that here. Here's a dir. And look, we've got all of our objects, just like you might expect. That's pretty neat. What if you come from a Linux background? ls does the same thing in Linux, right? And there we go. We get the same exact result. Very nice. The command in PowerShell, by the way, to look at a folder is called get child item. You can see right here, and if I type that, there we get the same thing. In fact, I can even abbreviate get child item with GCI if I want to, and hit enter, and I get the same thing. So there's 4 ways to get the same information here. What's really going on here is that get child item is really the only thing that's being executed when we type these various commands. The rest are what we know as aliases. And you can make your own aliases, of course, but there's a lot out of the box, and that's useful to know if you're not coming from a PowerShell background. You can just use many of the commands that you're familiar with. So there's copy is in there, cd is in there. So if I want to cd over to links, I don't know what's in there, you can just type cd links, and it come back up. cd ... And it goes up a parent folder exactly as you would expect it. CLS clears the screen. So these are all aliases for actual PowerShell commands, but you can use them interchangeably. Now we already covered parameters. There's so many parameters to these commands. I definitely recommend get help for anything that you're trying to learn about with the parameters. But I'm going to switch now to another feature of the language, which is called piping. Now anyone who has used Linux, or even DOS really, is familiar with this concept of piping. And the idea with piping is that you start with a command, and the output of that command becomes the input of the next command in the pipe. And you can string as many of these commands together as you like. So the output of one becomes the input of the next one, and so forth. So you can get some very expressive outputs from just a single line of input. So here's an example. So we did dir earlier. So the pipe symbol is the vertical bar, just like it is in Linux, many other systems. And we're going to pipe that to a command called format list. And there we go. So if you recall when we did just the dir, we just got a list of the items on the disk. When we pipe that over to format list, we get this nice verbose output. You may have a use for that. So that's how piping works, and you'll see some of those as we go through our demos. When we start executing scripts, there's a couple of things to keep in mind. First of all, by default, PowerShell has what we call an execution policy, and its execution policy is fairly restricted to begin with by default. That is for safety, that's for security purposes. So if you're going to execute any scripts on your machine, the first thing you need to do is you need to do set execution policy. You can see IntelliSense has popped it up for us there. And then if you type dash, you can see some options, and we want execution policy. And then we want remote signed or unrestricted. Remote signed is better. It's actually a little bit safer than unrestricted. And of course, you can lock it down as much as you need to here, but you definitely want to go remote signed if you're doing any kind of PowerShell development yourself. It'll give you this warning. We say, sure, go for it. And notice it denied us access. The reason it did that is that we're not in admin. So what I'm going to do is close this down. And we're going to come over here again, ISE, or right-click on that, Run as Administrator. And now with an administrator version, let's try the same command. Set execution policy, remote signed. Yes to all. And it works this time because we're in admin. Now you need to do this in order for your scripts to run. If you don't have this execution policy set, none of your scripts will run. Simple as that. So you want to start there. And when you go to execute a script from the command line, in PowerShell you need to start with a dot, and then you need to do your slash, and then your script, whatever it might be, right? All PowerShell scripts end in a .ps1 extension. That denotes PowerShell script. And in this case, we would run something called test.ps1. It doesn't exist, of course, but I just want to illustrate that you need to type that /, otherwise you're going to get some errors. Now, inside of a script, if you're trying to execute something, so let's say you've got a script here and you want to execute that same thing, you start with an ampersand. That basically tells PowerShell, okay, execute what follows on the line. And do the same thing, / and the name of your script. Okay, comments are denoted simply by this #. Nice and straightforward. I always say comments are better. If in doubt, make a comment. You never know when someone else might work on your code. You never know when you might need to work on your code and need a little memory jog, and that's what the comments are for. So in PowerShell, some of these lines can get super, super long. So if we have, we're going to do our get child item. And let's say we want to give it a path, right? So there's a path. Now let's say we want to give it a filter. And we want to say filter. And we want to do a force, and so on. As you can see, while I'm typing this, the line's getting longer and longer and longer. And this can cause some readability issues, especially when you start to do things like Azure commands or SQL database commands where there's really dozens of possible parameters. And so what you can do here is, we'll just say get path, and you do a space and a backtick. And that tells PowerShell, okay, well, we're going to keep doing this on the next line. Hit return. For readability, let's line it up, and we'll do a dash filter, space backtick, a dash force, space backtick, a dash recurse. You get the idea. And so now this is going to execute this command with all of these various features. And for the very last one, for the very last parameter, you don't do the backtick because you're done with the line. You just hit return. To write output, you just simply use the command write output, and that's going to give you something to write. We'll call that output. Now I'll execute that one line, and you can see it in fact wrote output for us. Useful for basic debugging or feedback to your users. Okay, so that's enough of those basics. Let's talk for a moment about variables. Now, you can use variables in the script. You can also use them right here on the command line. A variable in PowerShell starts with a $, and then you give it a name. So I'm just going to say $A in this case is equal to 1. And let's say $B is equal to 5. Now, if I want to, I can reference those variables, $A plus $B, and it'll add them together. You can also have string variables. So let's do $C equals our nice hello world. And to print the contents of a variable, you just reference the variable. Hello world. There it is. You can also use the write output that I mentioned earlier with the variable. And there you go. So variables are pretty straightforward. If statements are about what you would expect them to be. You have if, you have some parentheses, you have a variable, let's say A. The only thing that's a little different in PowerShell is instead of the symbol equals, say, you will have a dash, and your equality operator here. In this case, maybe it's equals EQ. And you say if A equals 1, and then you have your braces. You say write output, close the braces, execute that little block of code. There's a for each, which is super handy. And for each, you're just going to say item in items. So basically singular item in a list of items. And it's the same thing. You're going to have these braces, and then you're going to do what you need to do within the braces. You can reference item directly, like so. But you can also reference, there's a little shortcut, which is this $_. And you'll find that handy a lot of times, especially if you're in a loop, like a while loop or something that doesn't really have an iterator, like we have in this for each loop, and you can do that, and do a dot, and then do whatever property you need to call on it. So that's the for each loop. There's a try catch. So let's say, and this is just like you might expect from C# or something, you can do a try, you have your braces, there's some code inside the braces, and then you have a catch here, and you have some braces there, and you have some code inside of that. And what will happen is if the try throws an exception, it's going to execute this catch block. If it doesn't throw any exceptions, it will not execute the catch, and in fact go on down to the next line following the catch. You can also throw exceptions. If something goes wrong, you can just say throw, or throw an exception, and that will cause it to immediately exit out of the try and go to the catch. So that's pretty similar to other languages that I'm sure everyone has used. Now let's talk about string interpolation briefly. If you recall, we have the string variable C. We set that, and that says hello world. Now, string interpolation just means that you can embed that inside of other strings. So let's demonstrate how that works. You've got a write output, and you've got your string. There's your double quote, and we're going to say in there, we're going to say C, comma, Edward, that's me, and close it up. And notice it took that $C, it replaced it with the contents, which was hello world, and then it stuck that into the larger string. So that's string interpolation. The last two things I want to cover here before we get on to the meat of our presentation are arrays and hash tables. These both show up in our scripts. Arrays are simply going to be an @ sign followed by parentheses with stuff in the middle. So that right there is a null array, an empty array of nothing. We also have hash tables, which is really the same thing, an @ sign with braces. Now the difference between these two is an array is usually just a simple list of values. So let's illustrate this. So let's call this array 1, and we're going to say @ parentheses, and we're going to 1, 2, 3, 4, 5. And now if we print the contents of that variable, 1, 2, 3, 4, 5. And this is the kind of thing you could loop through with something like a for each loop that I showed a second ago. Now with a hash table, hash tables are just like array, but think of a key value pair. For hash table, we're going to call this hash1. And similar syntax, the @ sign except braces. This is such a small thing, but so important. Parentheses is for arrays, braces are for hashes. So we're just going to do a hash, and we can do just that, which gives us an empty hash. And then we can do things like hash1.add, which is a method on hash, and let's just add some information. So maybe we have a cat, and my cat's name is Scampy, right? And then we can do another one, and maybe we want to add a dog, and my dog's name is Gandalf. Name value pairs, very simple, and we can print our hash if we want and see all of its contents. And notice with the array it just printed 1, 2, 3, 4, 5, just this simple list. With the hash we get a column for name and we get a column for value, reflecting the fact that hashes are name value pairs. And that's it. That's enough PowerShell to understand what's going on with the scripts that we're about to look at. And now let's turn our attention to Elastic databases themselves.
Now that we've seen PowerShell in action, the next we're going to walk through is the Getting Started function. So for moving forward, we're going to be using the Wingtip SaaS database per tenant application, which is something that Microsoft Azure provides to customers so they can have like a big data set that kind of uses resources at an unpredictable level. And just so you can kind of see Elastic data pools in action. With this database, we're going to deploy and explore it a little bit further. In doing so, we're going to be granting access to source code and key scripts, kind of using the PowerShell that we discussed previously. Start is that we're going to be talking about how the dashboard works to kind of help manage and monitor your database performance over time, which is something that's going to be very useful and going to be definitely your friend moving forward. And then from there, it's going to kind of help you view how tenants are mapping back to a larger catalog, bigger catalog of databases within a company, and how they're using and reusing resource provisioning over time. And then from there, we're going to have a demonstration how we can set up our database pools, and then how we would provision a new tenant within the Elastic SQL pool we previously created. And then we're going to see our samples in action using the visualization tools. Now we're going to see a demonstration how you can get started using the Wingtip database software as a service.
All the code for our demos today comes from this project, the Wingtip SaaS application, which is located on GitHub. There's a lot of good information you can read through here, and so I recommend you check it out. Once you do that, come check out the documentation. To get started today, we're going to deploy to Azure by clicking this big blue button. When you go out here, all you need to do is enter in a resource group name and a username. I recommend the username and the first part of the resource group name be the same thing for convenience. Resource groups, recall, are just groupings of Azure resources. As you can see here, I'm typing in EDP demo 007 Elastic Database Pool, and that will be our resource as we go through these various demos. Beneath that, we'll enter in the user, which is just EDP demo 007. You have to select the I agree box down here and click purchase. Now it's going to go out and deploy those resources for us, which does take a little bit of time. However, due to the magic of video editing, we won't have to wait quite so long in this demonstration. And here you can see we have all the resources available to us. I want to call out specifically that there are 2 SQL servers and an app service, which is also a web app in Azure. The first of these SQL servers is the catalog database. Think of that as a template, if you will, that we're going to use to stamp out any new SaaS tenants. And then we have the tenants database server, and that's where all the tenants are actually going to live with their separate databases. Finally, of course, we have the web app. That's under the app service here. And once you click on that, you should be able to go out and just select it via a URL. The app service plan and traffic manager profile go with that, of course. So let's go take a look at our web application. Give it a second to load up here, and you see the URL up in the corner. You can also click this browse button here, and it will pull up our Wingtip Tickets application. We have several SaaS tenants already loaded. Here's Contoso Concert Hall, and you can see they have their own branding. They have some events that are unique to this particular venue. As we scroll through some of these events here, you can order tickets for any of these events if you wish. Just click the tickets button, pick your section, your price. Fairly straightforward little application here. Let's take a look at a different tenant. This one is the Dogwood Dojo, a different customer of ours who is exposing this web page to their own customers for people to sign up for tickets to their events. And the Fabricam Jazz Club, always a favorite, again with its own unique isolated information here for us to review. The tickets works as well, and these tickets apply specifically to Fabricam. the seats available, the quantity. Pretty straightforward web application, as you can see here. In addition, you can sign in to actually purchase tickets. Now, I don't think there's any actual authentication here, but you can see the form is available, and we could very easily put some authentication behind this if we so desired. But for the purposes of this demo, it's really not important. As we go back over here to the portal, and we're going to change gears from the portal over to PowerShell ISE. We're looking at a demo load generator here. And what we're going to do is start that up and generate a load using the script that we're browsing through right here. This is a SQL script. It's just going to create a kind of a dummy load on the system. And there are various parameters. So that lets us very easily determine if we're going to use regular load, if we're going to use a spiky load, whatever we want to use. Here, now that we've got our load running, we have gone and added Red Maple Racing. I know I'm flipping through these fairly quickly, but I think you get the idea. Our demo scenario is executing against the load that you see in the SQL script here. And while that load is on the system, and without taking anyone at all down, we were able to deploy Red Maple Racing, excuse me. And you can see it in the list of our information over here. A quick glance at the catalog. Of course, nothing changed here, but this is what we used to create Red Maple Racing when we loaded it up. Now let's go take a look at the tenants and scroll down a little bit. You can see, yes, in fact, Red Maple Racing is now the fourth database in our SQL Elastic pool here on the tenants page. So let's go back to the top level here and let's take a look at the pool itself. You can see, because we put the load on this pool, that toward the right it's beginning to spike just a little bit. And this is a useful indicator for if your pool is big enough or if it's too small, even if you're wasting resources and nothing is going on. And you can drill down, as I have here, into the database resource utilization itself. The 5 most active or hottest databases are going to be shown on this chart. You can see the little legend up there in the corner. And scroll down just a little bit for some additional information.
What an awesome demo. Tenant provisioning. The catalog pattern key is formed from a hash of the tenant's name. Here, the schema allows the app to construct the key from the tenant name included in the application URL. The catalog can also store additional tenant or database metadata, such as the schema version, service plan, or SLAs offered to the tenants. The catalog can enable database tools too. The provisioning pattern has a shared map along the users in the database. When a new user comes in, it allows others to share the same resources. There are templates available to allow users to provision databases in parallel. Daniel will now walk us through the tenant provisioning portion.
Now, the purpose of this demo is to actually load in a new tenant into our system. But this time we're going to walk through the debugger system to show you how it works on the back end. And then once we do that, we will load in a whole bunch of new databases which we can kind of use for our Elastic model. So here we are in our PowerShell. As you can see, we had a load running from our last demo. And then the top section is where we can see our demo section, where we can see the information on the tenant name, the type of code for various SaaS tenants. So we're going to create a scenario 1, which kind of goes down and calls this new one PowerShell canal with the new PowerShell tenant. It kind of shows you the resource group, the username, and the tenant name. It's all pretty convenient to have all this information, which you can use to create a new one. So in demo scenario 1, we can call the new tenant. We have it created. Next, what we'll do is step through the debugger to see what's going on the back end. So in this PowerShell, the catalog database management is where this information is being configured. So let's start by stepping through here. We're going to set the user, the configuration information, and as you can see when we hover, that's the user we set it up at the very beginning of the demo. Here's a configuration where we're reading in a bunch of variables from the PowerShell files. And here's our catalog. The next one is Bushwallow Blues, which is the one we typed in at the very top at our demo catalog. So it's been picked up here. It's been passed through successfully, in other words. And we have that name available to us. We validated the type here. We pulled the tenant key out, which is just the unique identifier for each tenant that we are putting into our database. So now we always want to check that we aren't having a duplicate in our database. And then we're going to go down and we're going to actually deploy our new tenant database, which is where the magic is kind of happening. So this command is going out, deploying the database, and waiting for it to complete its deployment. So when we hover over it, you can see that the database is successfully implemented. The second thing is to add the tenant database into the catalog, and then we can return the tenant key back into our demo catalog, into our provision catalog. So once we do that, there's a start process here, which is what it does is load in the new tenant, and then we have it running. So now, once we have one in there, we can switch gears and load in a whole lot of new tenants into the database, which simulates a real-life scenario where you can have hundreds and millions of tenants into an elastic pool, or in a system simultaneously. So for this demo, we're going to have about 20, just to kind of show off like how it works. So when we come back over here, create a new tenant batch, we will show you where it's picking up the config and the git configuration. Here you can see the catalog from the resource group. And then we have a symbol for each loop, which represents all the tenants and the hash, which is the configuration file which we're hashing from. We're going to look through this hash, and then we're going to deploy them to an Azure Resource Manager. And that template is going to apply all the resources we've seen, which ties back to all of these tenants. So let's go back here. Here's the code. Here's the code in the provision catalog. And basically, as you can expect, it's pretty straightforward. So you get the configuration, and we get the tenant names from the hash, and then we dial into the other PowerShell script. And here is that configuration. As you can see, we have a lot of constants here which control how the system behaves. And if you scroll to the bottom, it shows you our tenant name batch, which is just a hash, which is the at symbol followed by the braces. And inside this hash, we kind of show all the new tenants in our database. It's very easily structured, and if you want to add more, it's pretty easy to do. Just kind of follow that same format. So next we're going to go back to tenant name batch. Tenant name batch is where it gets picked up, and if we run it, now it's going to load all those tenants into the database. So with the magic of video editing, we went ahead and saved you about 35 minutes to kind of upload the new tenants into the database. Here you can see all of our databases for all of the tenants loaded in. As we scroll through the list of resources here, You can see which one you can see the blue oak jazz, which we added manually. And here you can see all the tenants are available on our web pages. Here's all of our tenants that we've cycled up, such as Cottonwood Concert Hall, just to prove that they've deployed successfully, and all these tenants are live and running at the same time in our software as a service system. Each one is isolated in its own database, but we are controlling the cost via a database pool. So now that we've got all of those loaded up, let's do one more thing. We're going to switch back over to PowerShell. And here you can see we started a load here on all of those tenants. And that load is simply using the same load generated script that we walked through before. It's the same load generated script from before, that we walked through via PowerShell. So this is a fairly stable load, but as you can see in a load, we can vary that and put in more diverse kinds of loads in our system, and we can see how the pool reacts with different scenarios of how load is managed over time. So thank you very much, and we will step back into the presentation.
Considering the pool load, how this can help you is by being cost effective for you. Here, the more databases in a pool, the more cost effective there is. The more people here are sharing more resources. You can use the performance monitoring tools within Azure to see the databases scaling up and down. Now, Microsoft Azure offers monitoring charts by aggregated data to show you the 5 hottest databases. You guys are going to love this because you can actually set notifications and alerts to let you know and will notify you of a specific utilization. If a database consistently maintains heavy loads, it will take up the resources from other databases. Looking up here at option 1, option 1 is to create a second pool and shift the busy databases into it. Now look at option 2. You can preemptively scale databases if you can predict the patterns of use. Now let's watch the dynamic loading in action with Edward again.
All right, let's really dive deep and take a look at some of these management patterns. First, let's go into the pool and take a look at the performance. Now you can see here that performance is spiked. It's capping at 100%, really flatlining up there at the top. And if we go into our database, you see the same thing. Extremely active. Most of these databases are up around 50-60%, which across 20 databases is going to really push this pool to its limits. Now as we scroll down, of course, we could swap out some of these. These are only the 5 hottest. And by the way, this is a great way to monitor your performance. I do recommend using this monitor tool. In fact, you can take this and put it on the dashboard, which we're going to do in a little bit. So let's start with an alert. Set up an alert. You come in here. You have a variety of different conditions from which to choose. Here's DTU percentage, for instance. And let's start with that. You can set it to average, max, min, whatever works for you. We'll set a threshold value of, say, 75% here. So if we're over 75% for 30 minutes, then we're in trouble. And it's going to trigger the alert. And alerting is a really good idea, too. You don't want to sit here and watch the graphs all day long, more than likely. And so alerts they do the job for you and let you know when something is wrong. So once we configure our logic here, click OK. And the next thing that we need to do is add an action group. Now this is telling the system, what do I do when my signal logic triggers? In this case, what do I do when we're over 75%? And what we're going to do is fire off an email. So we'll call this one EDP alert. And we'll give the action name email alerts. As you can see, you can have multiple actions per action group. You can have multiple action groups per signal logic. So you can really go kind of crazy here and set up all sorts of elaborate schemes to keep folks in the loop. We're going to keep it simple today, though. Let's just do this email right here. Click OK, and click OK. Now once you set up that new group, we're going to select it in our action group. And the nice thing, too, about setting up these action groups is you can kind of set them up independently of your various Azure resources. So you can use the same action groups for multiple different activities, and it makes it a little easier to set all these up. Now let's go ahead and give it a name. We'll call this DTU greater than 75 and select Create. Now that we've done that, you can see up in the corner, it is creating the rule. Once it succeeds, we can refresh, and the alert rule is right down here. We'll go in and take a quick look, and you can see there it is. It's created, it's enabled on SQL Elastic Pools. Now, coming back over to PowerShell, you can see we've got our load generator running. And it was generating just a steady load against the database. Well, now we're going to step it up a little bit, and we're going to generate a load with higher bursts per database. So the different databases are going to have bursts up to 70 DTU. And you can see here it's generating our load against all the various databases down there. You can see Red Maple Racing, Swirl Soccer, etc. All of the many tenants that we have added to this Elastic Pool. Okay, let's take a look at our resource utilization again. Things are pretty consistent with what they were a second ago. You can change the time range. And what we're watching for here is to see the load tick up. Sometimes it takes a little bit of time for it to reflect in these performance monitors. So while we do that, let's pin some of these monitors to the dashboard. Come back up here to the overview. So we'll pin the pool overall, and we'll pin the individual database line graphs to both to the dashboard. And that'll let us track these things a little more conveniently. Everything will be in one place. We can just go to our Elastic Pool dashboard, and we can see what's going on. Average utilization here of 99.81%. As we go back into our database utilization, now you can see it's really starting to spike up. Individual databases now are hitting 100%, whereas before the highest we saw with a single database was 60%. That's enough to make it 100% across the whole pool, but now individual databases are spiking up to 100%. We are taxing this pool to its limits. Let's take a look at our alerts. And you can see we actually have one alert has fired, and that's the one alert that we set up a second ago. And if we go in, you can see here is the detail. Our DTU greater than 75, you can see right here, monitor condition fired. And if we open it up, it's got a snapshot of what the pool looked like at that point in time, which is 100%. Well, 99.81%, close enough. The dashed line there is our threshold bar, and as we come to the history, you can see when we created it and when it fired. So that's just a little bit of overview about the alerts. Now, this alerting system works throughout Azure, by the way, but I wanted to show it to you in the context of pools because it's super important to know when your pools are having issues. So setting up a good alerting strategy is key to being able to manage these pools. And it should be something that you think through right from the start when you're planning a software as a service. Let's go to Configure. As you can see, we are running a standard tier here with 50 DTUs. Let's turn that up to 100 DTUs and see what happens. This is an example of scaling up. We hit save. Scaling is in progress. Once that scaling is complete, if we go back to our Elastic pool. Let's go back to our tenants database first, and let's select a new pool. And this new pool we're going to call Pool 2. This is our example of scaling out now. So we scaled up a second ago, and you could see that we were back under 100% once we had done that. We can change it up to, it starts at 100 in fact, because our other pool was at 100. But we'll scale this one back down to 50, because after all, if we're going to split these two pools, split the load between these two pools, it makes sense to have those back at their original settings. Together, they should amount to about 100. Now, once you click on this databases pivot, you can see I'm selecting just some random databases out of the pool. I'm going to select these, and we're going to put these in the new one. I've picked about half of these here. When you click Apply, it will immediately give you the feedback that they are right here. And click Apply again, and OK. And that will apply these settings. Now, it does take a little bit of time to move those things over. Deployment is in progress. But once that's succeeded, we should be able to take a look at our resources and verify that we have some good performance. Now, of course, this is a new pool, so it just spun up. And you can see it's using actually quite a lot of resources too. And that's because we're still throwing a substantial load at these databases. If we switch back over to Pool 2, we can see that it's still spiking up to 100%, but it's not staying up there. So we have successfully scaled this out, a horizontal scaling, which adds sufficient resources in order to deal with this enhanced load that we've got. Go ahead and pin that to the dashboard as well. And here in a moment, I'm going to move those around. Yep, there we go. Now you can see the resources for both the pools and the individual databases within each of our two pools, Pool 1, Pool 2. And let's go ahead and put a strong load on Contoso specifically. Now, Contoso is one of the tenants that we have here in this pool. You can see here, Contoso has been getting a similar load to all of the other databases as we go along, but once we start applying a strong load just to Contoso, you can see it really takes a strong uptick. Let's hit Configure. This is the other option that you have. So we scaled up by making the pool bigger. We scaled out by adding another pool. Now, we are going to demonstrate scaling up a single database, in this case Contoso, because that is the only one that has this significant load upon it right at the moment. So we can still scale these things individually if we need to. If, say, one of your SaaS customers has an incredibly higher load than your other SaaS customers, you can come in and just scale that one up and not have to redo pools and so forth. This is much better. You can see Contoso still has a heavy load, but it's not hitting 100%. In fact, it's averaging about 91%. So scaling up that individual database made a big difference. And now we have three options from which to choose. We can scale up by making the pool bigger. We can scale out by adding more pools. Or we can scale up individual databases that may be spiking independently of the others. Altogether, this gives us a lot of options for controlling our cost and making sure that our customers remain happy. Now that we've seen pool load in action, let's take a look at event deletions and how to recover from those. So in order to do this, we need to simulate a tenant deleting some data. And you're going to see here in a moment, we're going to open the events view to review some of the current events in our Wingtip SaaS application. Scroll down to the bottom and then accidentally delete that last event. Once we've done that, we need to restore that tenant. After we do our deletion, this is going to involve opening up the disaster recovery module, setting our demo scenario, and then we'll run a little script that's actually going to replace that existing tenant database with the backup. Keep in mind now, these tenant databases are being backed up automatically by Azure. So let's see all this in action. Accidents can happen. Sometimes events or even entire databases can be deleted, and we need for a way for our customers to handle these situations and get back up gracefully and without impacting our other SaaS clients. That's what we're going to simulate in this demo. Now, if you recall, in a previous demo, we had created a whole bunch of tenants in our Wingtip tickets platform. Let's zero in on Contoso for this demo. If we go into Contoso, you can see they're a musical organization and they have several events. Notice specifically at the bottom we have Moonlight Serenade and Seriously Strauss. Now let's go in and delete these, and we're going to pretend that we do this by accident, of course. Take a look at this PowerShell, specifically on line 19, demo scenario 1, where we're simply going to delete a couple of these events. Now, just for a reminder, we have Seriously Strauss, and we have Moonlight Serenade. Now notice, Seriously Strauss is gone. So this is what we're going to do. We're going to go ahead and delete Moonlight Serenade as well. But what we're going to then do is go through some of these scripts and demonstrate how we can restore the database back to its previous state. Now we're taking advantage of the fact that in Azure, these elastic database pools, the databases themselves, are being backed up in triplicate. And we are going to use that backup to restore these deleted events. So to do that, come in here, do a search for Contoso. You can see we have an old database here, Contoso Concert Hall Old, and that's going to be our old copy of the database. Then we have the current one, the one that's actually running right now in our production environment. Switching over to the database pool, let's come in and take a look at it from this angle. There's Contoso Concert Hall Old. Go ahead and select that checkbox. Come back to the dashboard and browse over to our application. Click the Browse button up in the corner and take a look at the Contoso Concert Hall that we have active right now. Just to validate, we have now deleted both of the bottom events. We're going to focus on Handel's Messiah. That's the one that we should be able, or sorry, not Messiah, the Moonlight Serenade. That's the one that we need to go ahead and restore. So now that we've accidentally deleted Moonlight Serenade, let's come back and take a look at our database for Contoso Concert Hall. It lives here in this pool. Give it a moment to load up. There's Contoso Old, and we delete that. Be careful to delete that, not the full resource group. You have to type yes here in order to get rid of it. So now that database is going away. You can see as we come back over to our PowerShell, we are going to select option 4 this time, Restore a Tenant in Place. This is running the necessary PowerShell to restore our backup copy of the database back to where it belongs, in place. In other words, we don't need to bring anybody else down. And let's just scrolling through the PowerShell here very briefly, you can see how it's doing it. So looking at line 84, restore tenant from the deleted database, we're basically checking to make sure that our database information is correct. And then we're calling restore Azure RM SQL database on the deleted databases. Now these are just standard Azure commands. There's nothing special about this for this particular demo for Wingtip SaaS or anything else. These are standard PowerShell commands that you can use to restore any Elastic database, or any SQL database rather. And we are using them to restore, in this case, our SQL database that just happens to be in an Elastic pool. You can see the various parameters there, include things like our resource name, the pool name, all the usual things that we've come to see as we go through some of these scripts. And now if we go back, we should be able to see our restored event once we refresh. And there it is, Moonlight Serenade. Mission accomplished.
Thank you for that amazing demonstration. I definitely learned a lot. So next what we're going to do is we're going to talk about cross-tenant reporting patterns. So with regards to reporting on databases, as you guys have noticed, it's very easy and pretty multifunctional to access and query and report on data from a single database. However, it's not easy when your database is spread across thousands of different databases within a network. So one approach that Azure offers is the Elastic Query, in which it allows queries to be accessible via multiple databases. One of the ways in which Azure can do this Elastic Database query is that they can start by creating a ticket and exploring global views within SQL select statements. This can be the specific statement that you are interested in reading a little bit further about. And then from here, you can deploy this ticket across all the databases used for distributed queries. And then from there, you can configure the head of the database for running distributed queries. What this would do is this would supply the data back or the reporting back that you're interested in from the Wingtip tickets servers. To see this a little bit further in action, we're going to walk through a demonstration of how cross-tenant database reporting happens.
Of course, once everything is running the way that it should, reporting is going to be a regular part of business activity. So let's take a look at how we report across multiple databases. This may seem like kind of a complex activity. After all, reporting typically just takes place against a single database at a time. But we do have a pattern available to us that we can leverage in order to achieve this with our software as a service across the Elastic database. Now I'm going to go ahead and log into my Azure account here, running this script that is going to demonstrate this activity for us. Give it a second to pop back up. And what we're doing here is we're running a scenario to purchase tickets across all the various venues. There's a lot of venues. This is a time-consuming activity, so of course we've got it scripted in PowerShell to automate the work of it. This is a test scenario, a test case really, that we're just automating in PowerShell for the purposes of this demo. If you watch down there at the bottom, you can see it's purchasing hundreds of tickets at a time at these various events, and it's just purchasing random amounts of tickets in order to achieve this. Now, we're going to skip ahead a little bit here because this does take about 20 minutes to run in order to get all of these tickets purchased. But you can see there on the screen that we were going database by database and doing these purchases. Now what we want to do is go out, we'll go to good old Contoso again, which we were studying in the last demo. Let's pull up some SQL and let's see what we get when we run this. If we look at, let's see what events we have going on here at Contoso. If we execute that query, you can see the events that we restored in our last demo. There at the bottom, for instance, is Moonlight. So going over here to the left, let's look in. You can see we have some views that are conveniently out here for us, and we are going to use Management Studio to actually create the script for us from that view. That's all that we selected there, and now here is the script, just to give you a sense of how that view is being created. Flipping back over here, you can see we purchased about 78,000 tickets. So now we should be able to actually run a little bit of reporting here and get some information back across all of our applications, if that's what we want to report on. Across all of our databases. Take a look here. We have a sample query. Select venue name from DBO venues. And this tells us which venues we currently have registered. You can see the familiar SaaS tenants down there at the bottom. Now this is just pulling this information out of our ad hoc reporting database, and we can actually look at the execution plan here and get a sense for how fast this ran. Now let's run this larger query here and figure out what is the venue type. It's the venue type looking across all of our various venues. And there you can see how many tickets we have purchased for soccer, for dance, etc. And now let's look at the execution plan for that. So you can not only study these execution plans, but you can actually do full reporting across the entire domain of your software as a service application, across all of the tenants who are subscribed to your application, in fact. You can use these analytics to determine what works, what doesn't work, how to save money, and opportunities for making more money.
So thank you again for doing this demonstration. Now that we've kind of walked through 7 demonstrations across Elastic Database Pool Modeling as well as Microsoft Azure services, to summarize, SaaS is a multifunctional computing format that allows users to access software that is private, secure, scalable, available, and offers performance benefits to users. Elastic pools in specific are databases that are useful to manage provisioning resources between tenants that have unpredicted spikes in performance that can use cases that drive up costs. We've walked through Azure's database softwares as well as the PowerShell softwares to kind of help users understand a little bit more about getting started, as well as tenant provisioning, pool load management, tenant restoration, and cross-tenant distributed queries. So thank you very much for your time. If you have any questions or have any concerns, feel free to contact us at our email. So thank you again.